33.
Oh, yeah. No, we didn't have to do
All right, 33 says, I'm not going to draw a scatter plot of the data. What that would mean is you're just going to plot these points. Now, what points would you be plotting? Be careful, because they set it up for you. If you just looked at the chart, you might think the points you're plotting would be this. Would you agree with that? Yeah. If you just looked at the chart. But did you read question A? They kind of changed it a little bit. What does it say?
X equals 0 represent 1990.
So 1990 would have, you wouldn't have 1990, you'd have 0. So what would this point be? It wouldn't be 1995, 506. What would it be?
0,
Be 5, 506. And 97 would be 7, 511, and so on. You see, that's all that first part's telling you, Tom.
Could you still do it the other way from 1995 to about 2000?
You absolutely could, but it wouldn't be following the directions. But
Okay.
yes, you could. I think the reason they wanted you to do this was because if you're using these, drawing the scatter plot's going to be pretty tricky. But yeah, it's still the same data. All right, so that's part A.
Oh, I asked her a question. I didn't need that one.
It's too late, I'm starting.
Okay.
Use the 1995 and 2000 data to write a linear equation and then superimpose, that just means draw the line on top of your scatter plot. Okay, they tell you specifically which points to use, right? Now why do they do that? Why do they tell us specifically use these 2 points? There's only one reason they do that. Think about it. How many points do they give us here? A whole bunch, right? How many does it take to write the equation of a line? 2. Okay. So what happens if Stripe picks the first 2, and you pick the last 2, and you pick the middle 2, and somebody else picks the first and the fifth? What's going to happen? We're all going to get slightly different equations, right? Now, is there anything wrong with that? No. But if we're all doing the same problem and we want to talk about it, isn't it easier if we all have the same, answer to look at?
Yes.
So they tell us use these 2 points. There's nothing special about those 2 points. They just picked them. So what are the 2 points they give us? One of them's 1995, and the other one was 2000. So that would be 10, 514. So we're going to use the circled points to write the equation of the linear, equation. So we're just going to write the equation of the line, right? So what do we do first to write the equation of the line? So m equals 514 minus 506 over 10 minus 5. So that would be what? 8/5? Then what? Point slope or slope intercept, whichever you like best. So y minus 506 equals 8/5 x minus 5. So y minus 506 equals 8/5 x minus 8. So y equals 8/5 x. Is that plus 498? Check my arithmetic. Now, what's the value of that equation? Well, the value of that equation is in order to answer these other questions. Suppose I wanted to know the average SAT score in 2014. That's not in my chart, right? So what would I do? Use my equation that I just built? So if I wanted to know 2014, where would I put the 2000? Well, tell me what I would do. If I want to know the score in 2014, how would I go about using this equation to accomplish that? I'm going to plug in the year to X, but I'm not going to plug in 2014, am I? Because remember we changed that?
That'd be 24.
So I'd put it in 24, because it's how many years after 1990? So that'd be 24 years. So I would plug in 24 right here, and then I'd work it out, and I'd get my answer. See how that works? Thank you, Brandon. Okay, Anna, what was your actual question then?
35.
Which one?
35.
35.
I'm just going to read for the sake of time.
Find the slope of the line in the figure. Okay, this is just your ability to read what you might see on your calculator, for example. It looks to me, let's just use the upper right-hand corner of the picture. The very, very upper right-hand corner of the picture. How far over did I count to get to that point? Okay, how far up did I count to get to that point? Now be careful. That's why you have to pay attention to your scale, to your window. How was your window set? In the X direction, it's negative 10 to 10, so that was right. You counted over 10. But how is that set in the Y direction?
It's 25.
It's 25 up. So what's your slope? You went up 25 and over 10, so it's 25 tenths or 5 halves. Got it?
Yeah, I just didn't know if there was a 10 methods to do it.
No, but you do have to pay attention to how your window is set. All right, who else found something you have a question about? Klein, what's on that iPad?
Oh, sorry.
Is it important stuff?
No.
Okay. 40. Solve algebraically. Okay, don't let the word algebraically solve or confuse you. That just means no calculator. Okay, that's what that means. Who's got a thought? Now, could I FOIL it out? I absolutely could. This is gonna, if I did, this would be a big quadratic equation, right? So if you are comfortable with that, you absolutely could FOIL it out and then get it set equal to 0 and use the quadratic formula. I would not because I'm lazy, and this is already set up with a perfect square in it. Do you see that? So I would probably divide both sides by 3. And then what? Square root both sides. Now, we're all going to get the same answer no matter how we do it, but this is just going to be a lot faster. So x equals 1 plus or minus root 7 over 3. Now, that's exactly what you would get if you multiplied it all out and did the quadratic formula. You would get exactly the same thing. Okay, anybody else? Remember, the next time we gather, you're going to be taking a test. So this is your last shot. Katie?
Numbers 23.
23.
There's a picture of it. Is that just a picture of it?
Oh, yeah. Okay, we have a line segment with endpoints at negative 1, 1 and AB. And we have the midpoint is 3, 5. So our job is to find A and B. Okay, we can do that. Who has a thought? Can you just count? Absolutely. That's the easiest way to do the problem. If this is right smack dab in the middle, let's just look at the x's. Just look at the x's. You're going from negative 1 to 3. How many steps did you take if you went from negative 1 to 3? 4. So doesn't it make sense that to get to the other end, you'd go 4 more? So if I go 4 more, this will be 7. Nothing tricky. Very good. Common sense. Now, we're going from 1 to 5. How many steps is that? 4. So this, I got to go 4 more, so this would be, there it is. There's your answer. Now, are there other strategies to do that problem? Sure. Lane? Oh, okay. There are other strategies to do that problem, but that works out perfectly. If this is the midpoint, then you're going to move exactly the same distance in the same direction. So if you went negative 3, you'd go another negative 3. That's it. Okay, Lane?
35.
35 we already taltalked about. Yes, we did. We said you got to pay attention to the scale. there, the x's are set from negative 10 to 10, and the y's are set from negative 25 to 25. So if we go to the upper right-hand corner of the picture, we count over 10 and up 25, so our slope is 25 points.
For 15, do you just like do the distance and see which way it is?
Show that the figure determined by the points is a right triangle. Okay, so you've got these 3 points. I'm going to go ahead and draw it like it's a right triangle. I don't know if it is or not. But you've got these 3 points, and you can find the length of each side just doing the distance formula, right? If it's a right triangle, then 2 of them squared have to add up to the third one squared. So finding the distances isn't enough. That's the beginning. Then you see, like if this is root 5 and this is root 6 and this is root 11, we're good because this is 5, this is 6, and that adds up to 11. But if this is 5, this is 5, and that's 11, then it's not a right triangle. Does that make sense to you?
Yeah.
The Pythagorean theorem has to work, in other words, for it to be a right triangle. So yes, you start with the distance. All right, anybody else?
This is like a quick question about what's the difference between bounded and unbounded?
Okay, that's not on your test, but it's a great question. It's in your book. Bounded means it's like contained. So if we think about if you think about a curve, and we're going to study these in the next chapter, so I feel comfortable talking about it. If you look at this is called an exponential curve. It is bounded below, but it is not bounded above. Because this one, it comes down, and it never really gets to the asymptote, but it keeps getting closer and closer. So this acts like a floor. It's not going to go past that. There is no ceiling. So this would be called bounded below, but it's not bounded above. A sine curve is bounded above and below because it never goes higher than this and it never goes lower than this. So bounded just means contained. It's like it has a ceiling or a floor. Okay? 50. Solve 4x squared minus 4x plus 2.
Yeah, my answer just feels weird.
Honey, the whole world is not perfect round integers. So do not panic because my answers look weird. That happens in real math. What did you do? Sure. So we have 4 plus or minus the square root of what? Negative 16? Yes. So that's 4 plus or minus 4i. Cancel a 4 out of everything.
Do you have to put the 1?
You have to have this one here now. Yeah. That holds that place. Randy, are you paying attention, sweetheart?
Yeah.
No, you're not. Focus, focus, focus. Maggie? Which one?
55.
55. 3x cubed minus 19x squared. Okay, this one says solve graphically. So this would be on the calculator part of your test. So how do we solve graphically on our calculators?
Plug it into y.
We would do y equals, right? We'd type in y equals, and we would see something. I don't know what this looks like. I was make something up. Okay, we see something on there, and what are we interested in? The X-Intercepts?
Yeah.
And there might be 3 of them. There could be as many as 3 of them. And so you got to find each one individually. And how do we find those?
We just do left bound.
Yep. First you go to second calc, choose up 0, and then start doing them left hand. Yep. Oh, by the way, yes, read just a second. By the way, if this had been a greater than or equal to problem, you would do exactly the same thing. You'd go through and find these points, right? But then your answer would be everything that was above those points. Remember that? That's how you would do that graphically if it were an inequality.
And if it was less than, it would be obviously below.
Okay, did you say 26, Reed? Find the equation. Okay, do not be confused by the extra directions they stuck in there. Your job in 26 is to write the equation of the line through these 2 points. So do you know how to do that?
Yes.
What do you do?
So it would be -9 over -7.
-9/7 is the slope.
So you
And
take y minus, or y plus 5, and x minus 2.
perfect. So we have y plus 5 equals -9/7 plus 18/7. So y equals -9/7 plus 18/7 minus 5, which would be 35/7. I get a common denominator. So your line is -9/7 minus 17/7. Now, that is perfect, except it's slope-intercept form, not they asked for standard or general, whatever they called it form, which they told you what that was. So you're just gonna take the equation that you got, and you're gonna rearrange it so that it looks like that. Okay, it's nothing confusing or hard. First of all, it's set equal to 0, isn't it? So you're going to move everything. So 9/7 plus y plus 17/7 equals 0. And then, normally, we don't like having fractions in there, so you would times everything by 7. But I don't want you to get all hung up by that. I mean, this is right here is the problem. Write the equation of the line given 2 points. This is just manipulation of the equation to make it look the way they want it to look. So let's not sweat that part. That's just moving numbers around.
Do 64.
Three x minus 5 over 4 is less than or equal to -1. Okay, what bothered you about that?
Wait, which one? 64.
Oh, no, that's not 64. That was 61. 64. 4x squared plus 3x is greater than 10. Okay, so what did you think to do with that?
Subtraction 10.
Oh, yeah, absolutely. We want to get a 0 there. Okay, then what occurred to you?
I don't know if I should do factoring or quadratic.
Okay, you can do whichever you want. I promised you that when I expect you to do one of these, it will always factor, but if you're not comfortable factoring, you can use the quadratic formula. I like to have the factors there because I know eventually, once I get all that worked out, I'm gonna go to my number line, and then I'm gonna be plugging numbers in. And if I don't have the factors, then I'm gonna have to plug them in this, and then I have to do arithmetic, and I don't have time to do that. So I'm gonna try to factor that. Now, I didn't write this problem, so I'm not sure it factors, but let's see if it does. Okay, that's not gonna work, but this might. I think that works. I need a +3. When I FOIL this out, there's my 4x squared, and here's my -10, right? And then this is an 8 minus 5, so that gives me my 3. So then, once I get it factored, then I can draw on my number line my 2 dots, which would be at -2 and 5/4, and they would be open. And then what do I do once I get that far?
You choose a number.
Any number anywhere. So what number do you want?
-4.
-4, which is out here. So if you put in -4, that would be negative, and that would be negative?
Yeah.
If we put -4 in? So if I multiply these two negative things together, will I get what I wanted? Yeah, because what's this?
Or greater than
Greater than 0 means what? Positive. I want positive. If I multiply a negative and a negative, I get positive. So that works. That won't. This will. So your answer is everything less than -2 or greater than 5/4. Okay? Don't get confused. Don't say, I don't know how I should do this. It doesn't matter. Ultimately, it doesn't matter. It's just, I think it's, my choice is if I have factors, I think it's easier.
81.
81 says, okay, projectile motion, I told you I'd give you the formula, so let me write the formula up here. And then we're gonna have to plug some numbers into it. The problem will give us numbers, hopefully, to put in. So it says it's launched straight up from the ground with an initial velocity of 320 feet per second. So how does that help me? Straight up from the ground, initial velocity of 320. What do I put in here?
320.
320. What do I put in here? What's supposed to go in here? What's this letter represent?
How high you started.
Yep, the starting height, right? What does this problem tell me about my starting height?
On the ground.
It's on the ground. So how high is it above the ground if it's on the ground?
0.
0. That's a 0 for this one. So here's my equation that I'm going to use right here. This is the equation that now is going to help me answer all the questions. And what did we, I keep trying to hammer this home. You've got this formula now, this equation that you're going to use to solve these problems, right? They got to give you, there's two variables there. They got to give you one of them. And you just plug it in and figure out the other one, right? So what's the biggest choice you have to make? What do I plug it in for? So look at problem A. What's the number they gave you? 1538. That's 1538 feet above the ground. So where are you going to put the 1538? Right here, right? This is the height. This is the height above the ground. So you're going to put 1538 here, and you're going to have this equation to solve. So how do you go about solving that equation? Well, you can't plug anything into anything yet. What do you have to do first? Get it set equal to 0. So you're going to move this over here, you're going to move this over here. It doesn't make any difference, but you got to get it set equal to 0. So I'm going to do it this way. Now it's set equal to 0. Would somebody check, is that number by any chance divisible by 16? Because that'll make it a lot easier if it is.
That's not.
It's not?
Well,
Okay, then let's just, I was gonna say let's divide by 16, but not, let's not if it's gonna be a fraction. So, what do? I plug it in the quadratic formula. This will be on the calculator part of the test because the numbers are just hideous on here, so you can use your calculator. So you just type it in, put in the quadratic formula, and crank it out. How many answers are you going to get? 2, right? And we've talked about that before. Why do we get 2? Here's our projectile being thrown up into the air. Here is 1,538 feet right here. Why are there 2 answers? Up and down, right? So we should expect to get 2 answers. So we can use the quadratic formula to get them, right? Okay. Next question says, when will it be at most 1538? At most 1538. Well, this is where it equals 1538, right? Did anybody do this by any chance?
That means it's less than.
Do we have answers here? Anybody know what those are? Okay, well, they're numbers, some numbers, okay. What does at most mean?
That means that it's
less
less
than
than.
It's less than that. So wouldn't those answers be here and here?
Yeah.
Now, here's the deal. This would go from 0 to whatever that is. And I don't know what that is, and I hesitate to take a guess because then it won't be right and then someone will get confused. But I really need to know what that is. So I'm just gonna say, I'm gonna guess. Let's say that's 6 and this is 12. I'm just guessing. Okay? Actually, let me make this something different. Let me make this 18. Okay? Those are not right answers. Is everybody hearing me say that?
Yes.
Those are not right answers. I'm making it up. But the reason I want to make it up is because when I answer this question, I have to say from 0 to 6, right? And then I have to say from 18 to here. Now, we talked about this the other day. What's that?
24.
How do we know that's 24?
Because it's 0 to 6.
Because if it took 6 to get up to that point, then it's going to take 6 to get back down, right? So the answer here would be 18 to 24, but those are wrong answers. I just was using those for illustrative purposes. We first have to figure out what those numbers are.
How do you figure it out?
Okay, parabolas are symmetric, okay? So if it took me 6, and I made that number up, if it took me 6 units to get to here, then it's going to take me 6 units to get to here. Everything is completely balanced. There's an axis of symmetry. Everything is completely even on both sides of the parabola.
Wait, how do you find those numbers? On the bottom.
You solve the quadratic formula. We talked about that. These are big numbers, and we've practiced. We shouldn't have to use our review time to do the quadratic formula. You know how to do that.
Yeah.
So you're going to crank in the quadratic formula.
Okay.
You're going to get 2 answers.
Okay.
That's what these are.
Okay.
Okay? Or you could try to complete the square, I wouldn't, but you can try or something. Somehow solve that quadratic equation. And then, when will the projectile's height above ground be greater than or equal to 1538? Well, that would just be this, right? So using the numbers I had up there, which weren't right, made up, using my made up numbers, it would be between 6 and 18. Now, another question that I've asked that is not asking that question is, when is the ball on the ground? Well, we know that already, right? And using the made-up numbers 6 and 18, when would the ball be on the ground? At 0 and 24? I could also say to you, when is the ball at its highest point? Well, using my made-up numbers, if this is 6 and this is 18, and these are totally made-up numbers, if this is 6 and this is 18, when would it be at its highest point? 12? Because won't it be right smack dab in the middle of everything? So then if I said, what is the ball's maximum height? Now you figured out that it happens after 12 seconds, right? So how would you figure out how high it was at 12 seconds? Plug in 12 to the original equation, and that would tell you how high it is there, right? So all those questions could come from this problem also. What are you doing? Put it away, turn it off. How can I love you? All right, anybody else? What else? What else?
63.
63. 63 is an absolute value inequality. Remember, you can solve these any way you want. Just make sure you're getting the same answer I am. I will use the calculus approach here. So 2 things about this problem. One is this 3, so I'm going to divide. Now, if you do the problem a different way, you don't need to do this, but remember, I'm gonna do them all this way, because this is the way we do it in calculus. So I'm gonna divide everything by 3. Now, I'm going to interpret this always, always, always as a distance, and therefore this has to be a minus. So do you remember how I got around the fact that it's a plus? I made it minus a minus. So this says the distance between something and negative 4/3 is 2/3. So I just count out 2/3 this way, which would put me where? Negative 2/3. And I go back this way 2/3, which would put me at negative 6/3. Those are closed dots because of the or equal to. And then my answer will always be the numbers in between the dots or the numbers outside the dots. This is a greater than problem. Greater than problems push out beyond the dots. So my answer is everything less than or equal to negative 6/3. Oh, that by the way is 2, isn't it? Or greater than or equal to negative 2/3. Now, no matter how you do the problem, that needs to be your answer. So if you're getting that answer, you're good. If you're not getting that answer, then you need to redo.
So you don't have to plug anything in for these ones to find out.
No.
What are the ones that you have plugged in for? Those ones? So it's just, so it's a quadratic figure as well.
Or any polynomial. Wouldn't have to be a quadratic, any polynomial. Absolute values will always be shaded either between the dots or outside the dots. There's no yes and check there. It'll always be yes. Now, Anna, if you wanted to check regions, that would work. You just don't have to, because there's no chance of anything different happening.
Number 22, I have in the absolute value, I have x plus 3, but should it be x minus?
No. Her question is about number 22. It says use absolute value notation to write the sentence. The distance between z and negative 3 is less than or equal to 1. The distance between z and negative 3, so that should be a plus, because it's actually a double negative, is less than or equal to 1. Okay. Madeline?
On 68, like the x, it confused me because it's like not x cubed, like it's just
4x cubed minus 9x plus 2. Okay, this is number 68. Okay, now, this, if I gave you this question, it would be a calculator question. And you would do what we talked about before. You would say, okay, y equals, you type that in, you'd see where it crossed, who knows, where, I don't know, maybe this one looks like this. I'm totally making this up. This would be the answer to the question. That's where it equals 0. So then you would say, okay, it's above 0 or more than 0 in all this part. So if this answer was 5, it would be all the x's bigger than 5. If the picture looked like this, then you'd have 3 answers to find, and it would be this part and this part, right? Now the other kind of problem like that, are you sick? You need to go to the office?
no.
Okay, because we're either gonna be here and be attentive, or we're going to the office. If you're sick, I want you to go to the office, but otherwise I want your head up, okay? The other kind of cube, though, this is a certain kind of cube that we're not ready yet. We don't know how to do that in chapter 2. However, you can do this kind. This kind you can do without a calculator, because this one, even though it's a cube, this one factors. Now, this one may factor also, but it doesn't factor by any techniques that we have talked about yet. This one you could factor by grouping. And so I would expect you to be able to do that And then you have x squared minus 9, x minus 4. You following along, Madeline? That's looking familiar? And so x plus 3, x minus 3, x minus 4.
Yeah.
Then I would go to my number line, and I would plot those 3 points on the number line. And then I would check the regions and do it that way, okay?
Okay.
So if it's this problem, that's gonna be on the calculator part, and that's your strategy.
Okay.
If it's this problem, it will be on the no calculator part, and that's your strategy.
If you didn't use a calculator for that, would the right way to do it be like, would it be to carry the 2 to the other side?
No.
How would you do it if you didn't?
Okay, we haven't talked about that technique yet.
Okay.
We haven't, we may have done it last year, we have not, so I'm not only responsible
Okay.
for it. There is a technique, we will be factoring things like this by hand, but I'm not expecting you to do that at this point. That question would be on the calculator part, I would expect you to graph it and do it
Okay.
that way. This question would be on the no calculator part, because that kind of factoring we have talked about. This does not group. And sometimes kids see 3 terms and think quadratic formula, and go, no.
Yeah.
It's not quadratic.
I didn't know we had better calculators when I solved it. I just put the 2 to the other side, I don't know if it's right, and then I put x in front of the 4x squared minus 9. And then I don't know if it's right, I just did 2x minus 3 times 2 is plus 3.
And then what?
And then I just did x is less than -2, and then solved 2x minus 3, yeah. It wouldn't work that way.
The only time you can take factors and set them equal to whatever, like if this is a 2 over here, you can't say this equals 2 or this equals 2. The only number that works for is 0. So our equations are always set equal to 0. We never move, the only time we would ever move that 2 over is if we were gonna complete the square. Otherwise, we never move that.
For number 64, what was the, or answer? I don't know if we.
I did that one. I did 64, but I erased it.
What was the answer for it?
I don't remember.
Oh, I thought you had the answer.
I don't remember. I did that one though, so if you scroll back to the video, you can see I did it. Okay, so what are we doing for Monday? We're finishing that assignment. And when you come in on Monday, you will all turn in that assignment. So have it ready to go. It'll be multi-pages. Have it stapled together with your name on it. We'll turn that in, pick up a test, and we're off and running. Make sure you have a functioning calculator that you know how to use. Right? Sit down.
I just remember, you know.
Open gym on Sunday, 2 to 4. So if you feel so inclined, bring a friend. Always come with a friend, never come alone. That's not good. Come with a friend. I will be there, so I can help you with questions if you have them at that point. I gotta help other kids too, but. Math league sign up starts next week. $3, you give it to me. Does it matter? You don't do math league anyway, right? So it really doesn't matter, right?
I had a really bad dream about APU last night.
Anna Fran, don't put 2 boxes of Kleenex.
I put it in my phone, everyone like,
You had a bad dream about APD.
yeah, I had a dream.
That's when you know.
So this one I said was, that's a little weird, that was would be a calculator problem because we haven't learned how to factor that yet.
But like I have my project
That one would be number
it's like
one.
really weird and like rest of it. So like I'm
Now
like
that
that.
would be done.
Well, that's like my project. I was measuring like the project back. And so I just bought a navy poster board and like made the gap symbol that had the GAP like 3D. So I bought like wooden letters. And then took corks on the bottom of them. And so it all like, it looks good. It looks good flat. I don't know, it just looks so.
Bye, Mrs. Ford.
It looks
Bye.
good, like, flat.
Oh, hi. You're coming in. Bye. I got them coming in, going out. What's in the pizza box?
My project. You wanna see?
What is it? I'm eating my oatmeal.
It's not edible.
Oh, what is it made out of?
Play-Doh in a plate.
And so what's this project for?
Economics. So Edward J. DeBartolo Jr. And he owns
Oh.
a pizza company.
And-
Unfortunately, I forgot all my paperwork at my house in my binder with another binder.
Uh-oh, what does that mean?
I'm gonna have to turn it in Monday.
What was the goal of the project, or the purpose of the project?
Entrepreneurship.
So that guy started the business?
He didn't really start this business, but he is very. He's like a billionaire, $3 billion.
You tricked me.
You can't eat it, Minch.
What is it?
Open it.
Can I at least see what it is? Oh. That econ project?
Yeah.
You just played the
It's for,
biggest
you
trick
know how
on
to
me.
solve the Rubik's Cube up there?
We're not playing with Rubik's Cube.
I know how to do it.
I don't doubt that one
Wait,
bit,
dude,
Tyler, that
Colin Roberts, no matter what, can solve it in under like in 30 seconds.
Really?
Yeah, no matter how much. The sticks, we have like this thing
Okay, so what is that, Lenahan?
Baseball for my
Who's your guy?
Mr. Wynn. Oh, John W. Henry, the owner of the.
I made a, actually, I made a garment.
That's actually good.
What is it, William?
My guy created garments, I had to make like a.
Patrick, your parents came in and sat right there last night. It's right there.
They did it also in English, they told me, and in sports,